libraries for descriptive statistics, data visualization, and exploratory research. Going further, today in the last day, we'll learn about predictive data analysis, and this session will be taken up by Mohammed Amir. I think he's among us with us. Now I request my colleague CA Nita Sahu to introduce Mohammed Amir to start the session. Nita ma'am, over to you.
Thank you, sir. Thank you, Ritesh, sir. Good evening to all of you. Dear participants, today we have with us Mr. Mohammed Amir as resource person for today's session. With your kind permission, I just want to introduce Mr. Amir. Mr. Amir is highly skilled and experienced tech professional in the field of IoT and AI. He is an innovative professional in tech solution development, content curation, and content delivery around IoT and AI. He is certified in machine learning by Oracle Cloud with autonomous database. He is Intel certified instructor for machine learning using one API. Mr. Amir has certified in multiple technology tools and frameworks. He is proficient in machine learning, artificial intelligence with Python, Python programming, building IoT solution, and automating tasks with robotics process automation. He has mentored various projects around IoT, computer vision, automation, and artificial intelligence. He is member of Times of India NIE 2020. He has conducted more than 200 workshops, webinars, and training programs covering Pan-India and catered to more than 8,000 participants in various technologies. I, on behalf of AKGIM and participants, welcome you, sir, on 5th day of this FDP on machine learning. Now I request you to kindly take over this session. Mr. Amir, please, sir.
Yes, thank you, ma'am. Thank you so much. I hope you are able to hear me.
Yes, sir. Absolutely.
Fine. We'll begin the session. Okay, let me share my screen and I will begin the session for the day. Please let me know if my screen is visible. Are you able to? Okay, wait. I think so. It is presenting.
Yes, sir. It's coming.
Yes. Fine. Okay. If there is any interruption with respect to my voice or maybe the screen is not visible, please let me know as we go forward with this session. Fine. So let's begin with this session. I am very excited to be amongst all of you to teach some of my experience with regards to machine learning. So I will not be teaching you any theoretical part today. Today's session is going to be more of coding, and I want you to do the coding along with me. So in the previous days, we have, you might have already seen, first 4 days, there was the introduction to machine learning given, and then how do we use machine learning with respect to Python programming, what is EDA, then you might have gone through several libraries, NumPy, Matplotlib, and then Pandas library. So today's session is a culmination of whatever you have learned today, and as I've told you, it will be focusing more on the practical part. So I'll just open a notepad. If in case I want to write any specific things here, I can probably mention it here, and I will be using the tool for doing this particular predictive analytics part. Okay, so I have a couple of questions. If you would help me understand a couple of things here, it will be very interactive and it will be easier for me to take the session forward as well. Tell me which are the libraries which you have learned, or even before going for libraries, which is the software which we use for artificial intelligence, machine learning, or data science? Which is the tool which you have used? Can someone tell me? I want answers from your end. That will be better. If in case you want to unmute and speak, please feel free to do that, or else you can probably write them in the comment section as well. I'm not able to see the comment section here. Let me check.
Jupyter, sir.
Yes, Jupyter. Okay, comment section is here. Fine. It's Jupyter. Jupyter Notebook is what we use. Can someone tell me which programming language do we use inside Jupyter Notebook? Jupyter Notebook, that's great. So I'll just write here predictive analysis tools. Which programming language do we use?
Python.
Python. So programming language is Python. Yes, that's great. Okay, next thing is in Python, which libraries you have learned? You might have gone through a couple of libraries. Just one by one, can you list them? Which libraries you have learned? Sorry, I couldn't get that.
Matplotlib.
Matplotlib is what you're talking about, I believe.
Yes,
okay,
sir, yes,
even
sir.
before Matplotlib, you must have gone through NumPy. We'll start in order. Okay, so NumPy is a library for numerical computation, correct? Numerical computation, whatever numerical analysis you want to do, you go ahead with NumPy. After that, whatever data you want to gather and you want to visualize it, that is when we use Matplotlib, correct? This is a data visualization library. Okay, one more library which you might have gone through maybe yesterday's session. Which library? Pending one, another library. Or are these two libraries only you are familiar with? There's another library which you might have gone through. Can someone tell me that? Last library name? No. You must have gone through Pandas. Pandas is another library. Right, so Pandas is a library for data analysis. So exploratory data analysis base was actually considered on Pandas library itself. So these three libraries you might have gone through. Today, I want to talk about another library, which is what we call as Scikit-Learn. So this is a library which helps us to implement machine learning algorithms. So if you want to apply machine learning in Python, we use a library called as Scikit-Learn. Now, this Scikit-Learn library has got various algorithms embedded inside it. I'm going to show you a quick walkthrough of the documentation of Scikit-Learn as well. So there are multiple algorithms which are actually present here. Now, when you are using Scikit-Learn, you might have to do some analysis of data, which is when we will be using Pandas library. You might have to visualize the data, which is when we will use Matplotlib. You might want to do numerical analysis on it. That is when we will be using NumPy. So these are the secondary characters for the main value addition what we are going to do. Scikit-Learn is our main library in machine learning for Python. Along with that, we might need the additional libraries. Okay, fairly simple. Along with these three libraries, we are going to use the main library, which is what we call as Scikit-Learn. So Scikit-Learn is a library for implementing machine learning, or we also call this particular thing as predictive analysis. So predictive means you try to understand one specific intention of a machine. You try to understand what the machine will tell. For example, in predictive analysis, there are a lot of different things. I'm sure you must have gone through the different types of machine learning. We have got supervised learning, unsupervised learning. We have got the combination of supervised and unsupervised called as semi-supervised learning. We have got regression analysis, classification analysis, and a lot of different things, right? So each and every analysis actually deals with the prediction. You're trying to predict something, right? This is easily implemented with the help of Scikit-Learn library. So I'll quickly show you how this Scikit-Learn library actually looks like. If you go to Scikit-Learn on Google, you get to see this Scikit-Learn machine learning in Python. Okay, this is, I would say, a very, very important, very critical website. If you want to understand the aspect of predictive machine learning, you will have to go through this particular site. And if you see here, you would be very curious to understand most of the things. So you can see here there is classification mentioned, regression mentioned, clustering mentioned. Just a quick overview of what exactly is classification. Classification helps us to identify which category an object belongs to. Does it belong to category A or category B in terms of binary classification, or category C or D in terms of multi-class classification? Regression means what? The output, whatever you have, will be continuous. Okay, it will be in continuous value. Clustering means automatic grouping of similar objects. That is what we call as clustering. Now, the best part here, which I want to highlight, is Scikit-Learn in the backend is actually built on NumPy, which I've already gone through, Matplotlib, which I've already gone through. There's another library called as SciPy. There is another library which is used for scientific computing. So this forms the base for this Scikit-Learn library. Okay. Now I'll tell you the agenda, what I want to go ahead and want to consider. I will first implement simple linear regression, okay, with respect to Scikit-Learn library. We'll take one real world data set and we'll implement this particular part. The second thing what I want to implement is something with respect to classification. I'll implement decision tree classifier. Okay, these are the two things which I want to quickly implement, and I want to show you the model building of it. Okay, so linear regression, this falls under regression part. Decision tree classifier, this falls under classification part. Fine, these two things we are going to see practically, and I would recommend everyone to do it along with me. So obviously, as you have mentioned, we are going to begin with respect to Jupyter Notebook itself. Fine, I hope Jupyter Notebook is ready, up and running for you. Let's get started and let us see what exactly is the simple linear regression and how do we implement it using Scikit-Learn library. I want you to remember regression means output variable. The output, whatever you are considering, will be continuous. Continuous means there is no range. It can be from any value to any value. Okay. Please remember this. Regression means output value. The output target will be continuous. Classification means output value will be discrete. Either it can be 1 or 0, or it can be mango, apple, or orange. You know exactly what will be the output. Either it will be this or that, or it will be 1, 2, or 3, whatever it is. Okay, based on binary or multi-class classification. Fine. So let us get started with the regression part. The regression means output will be continuous. Okay. I'll give you a data set link which I want you to download. So it's actually available on Kaggle. Kaggle, if you don't know, is a place wherein you get real world data sets to work upon. Okay, so I'll download here one data set called as salary data. I'll provide you the link, don't worry. You can consider downloading this particular data, and then we can go ahead with respect to this. Okay, this is the link of the data set which is hosted or which is available on Kaggle. So Kaggle is one specific website wherein you get plethora of data set. You can actually enroll for data science competitions as well. But for now, we are taking this data set part. So can you please go to this particular link? You'll have your option called as download. You'll have to download this particular data set. Let me know once your data set is downloaded. I'll also download it. You can see here salary_data.csv is downloaded for me. If anyone is facing any issue, please let me know. I'll help you out. But I think so you should be able to download this particular data set very easily. I will not be able to send it via this chat. I believe Google Meet doesn't support that. But then everyone should be able to download this particular salary data set very easily. Until then, I'll keep my Anaconda prompt open. I'll just open my Jupyter notebook. Fine, my Jupyter notebook is up and running. Let me just go to one folder. I'll create a new folder here named day 5. Okay, rename it to day 5. I'll be sharing this particular folder with you at the end. Fine. Okay, what do we do now? On the right hand side, you have got new option. Click on Python 3. You're creating a new Jupyter notebook here. Now here, I will click on upload and I will upload the CSV file, which I have downloaded from Kaggle. I'll upload it here, CSV salary_data.csv. Just click on upload here. Fine. Are you ready with this? Can I get a quick confirmation if you are ready with this? Yes, no, if anyone is
Sir,
facing an issue.
Kaggle is asking for login ID password. I think email ID.
What you can do is, if it is asking you for email ID password, you can just sign in via Google. You'll have option to sign in via Google.
Okay.
So with your Google account only, you'll be able to sign in. I can just show you here. I'll just open it in incognito. So when I click on download here, it will ask me for signing in. Just click on sign in with Google and give your Google ID, normal Gmail account, whatever it is. You don't have to create anything new. Just sign in. Kaggle, by the way, is a subsidiary of Google itself. So with its API, it will get connected. Okay, how about others? Do I move forward or do I wait? I believe everyone is in sync with this. Okay, let's go ahead. I would assume that everyone has downloaded. I'll just write in here linear regression.
So after downloading the sheet,
Yes.
can you repeat the step where we need to update, where we need to upload it?
Yes. So open your Jupyter notebook.
Yes.
Open your Jupyter notebook like this. You'll have option upload here. Okay. So click on upload and whatever you have downloaded, right, the CSV file, just open that. So what you are trying to do is, in this environment, you are trying to connect the CSV file with the notebook, Jupyter notebook, whatever you are going to use. So the idea is, in your Jupyter notebook file, your CSV file and your notebook should be in the same folder. So this is in the same folder named D5. Okay. I will start by importing the necessary libraries. First, I'll import pandas here. And I'll create a data frame. So data frame is a structured way of maintaining the tabular data. Okay. I can write here df is equal to pd dot read underscore csv, which means I am reading the CSV file.
Excuse me, sir.
Yes.
Excuse me, sir.
Yes.
Just please increase your font size, sir. Please.
I'll increase. Sure. Is this fine now?
Yes, sir.
Yeah. Okay. So what I'm doing here is I am importing pandas library as PD. PD means short form. Okay. And then I am reading a CSV file. This is my CSV file. And I'm going to consider writing the same name, salary underscore data dot CSV. D is capital. Yes. That's it. And then I'll display top 5 values. When I write df.head, it displays top 5 values here. So if you see here, years of experience, there's this first column, and then salary is the second column, which I'm getting. I'm copying this code and giving it to you. If in case you want to just copy and paste and check the output for yourself, you can do that. I have given you the code. What I've done here is I'm just importing the CSV file and I'm displaying the output. So you can see here the value, the column, what it states is years of experience first and then salary. 2 columns are there, right? 1.1, if someone has got 1.1 year of experience, then that particular person's salary is 39343. Then 1.3 years of experience, this is the salary. 1.5, this is the years. So actually you are taking different people's experience and their salaries. This is the data what I have. Now what I have to do is I have to build a linear regression model wherein I will be able to predict the salary of any person who has got some amount of experience. What if you have been asked to develop a machine learning model to predict what exactly is the salary or what exactly should a salary of a person be if that particular person's years of experience is, let's say, 1.2 or maybe 2.2, okay, something which is not mentioned in the data set. 2.2 is there, okay, let's say 2.3 or 2.5 or whatever it is. How will you get the output for that? That is what we are trying to achieve here. First of all, whenever you get any data set, try to identify whether it belongs to the regression part or classification. How do you check whether it is regression or classification? Regression means the output should be continuous. Now, differentiate between these two columns, which is your input column, which is your output column. Or in other way, can I say that I want to know which is my independent column and then which is my dependent column? Can you tell me out of these two columns, which is dependent on what? Which column is dependent on what? Tell me which is independent column, which is not dependent on the other column, and which is dependent column.
Year of experience is independent column.
Year of experience is independent, right? Simple.
And
So salary is dependent on year of experience. Thank you so much. So independent column is years of experience, salary column is dependent. That is what you get to see. And we can see here that the dependent column is continuous as well. Obviously, even the independent column is continuous, but then we are focusing on the dependent column, the output column, right? And this is what we call as the output column also. Okay, fine. What I'll do is, to make my data much more clearer, I'll import matplotlib. Okay, matplotlib, I'm sure you know how to import it. Import matplotlib.pyplot as plt. And then what I'll do is, I'll write here plt.scatter. On x-axis, I will take the value of df of let's say years of experience, which is obviously my independent variable. And then I'll take df of, let's say, salary, which is my dependent variable, and I will show the output. So the moment I run this particular code, what do you see? I'm giving you this particular code. Let's try to understand. Let's try to analyze this code. You can see here on x-axis, I've taken years of experience, and on y-axis, I've taken salary. I get to see that as and when the years of experience is increasing, there is a tendency that the salary is also increasing, which means that there is a relationship between these two parts. When when years of experience is increasing, salary is also increasing. This is what we call as linear relationship. Okay, this is important. With the help of visualization only, we'll be able to understand there is linear relationship between years of experience and salary. So when there is linear relationship between these two columns, we can now go ahead and we can apply the predictive analytics using linear regression. Okay, see what we have done. We have used pandas library to get the data frame, and we have used matplotlib to understand the data relationship. Now we know that there is a linear relationship here. We will now go ahead and we will apply the concept of linear regression. Now let me tell you what is regression in the most simplest manner. What exactly is linear regression? So regression is actually a statistical concept which tells you the relationship between two different columns. Okay, 2 or 3, whatever you consider. For now, we are taking two columns. Or you can say between dependent and independent column, what exactly is the relationship? And if the relationship is linear, then you go ahead with linear regression part. If the relationship is non-linear, if the relationship is, in a little different variant, then we go ahead and apply something called as polynomial regression. We have got different other types of regression. We are just focusing on simple variant right now. So we know that the relationship is linear. Linear means what? If one is increasing, the other one is also increasing. If one is, let's say, increasing, if the other one is also decreasing, then that is also something called as linear relationship. I can show you the example of non-linear relationship. Non-linear regression. So there will be a relationship, but it will be a little different. So if you can see here, this is not completely linear. It is going up, but then it is coming down also at later stage, right? This is what we call as non-linear regression. Okay. So the first variant, what I have shown you, this is what we call as linear regression. Can you see here? With increase in x-axis, y-axis is also increasing. You can have quadratic regression, you can have cubic regression, different types of regression are actually available. Linear means the line what you can consider here can be best represented with the straight line. So what we will do now is we will put a straight line here and we will find that best fit line wherein it actually will have the minimum error possible. Okay, we will have a best fit line wherein the minimum error possible will be considered. That's it. That is my whole idea. Now, in linear regression, what do we find? In linear regression, find the best fit line. And the best fit line in terms of linear regression is always a straight line. Always a straight line. Can someone tell me what is the equation of a straight line? What is the equation of a straight line? The equation
Y equal to A plus BX.
Yes. You can write y equals to a plus bx or mx plus c. Whatever it is, you can represent
mx
it in
plus
any
c, yes.
manner. Doesn't matter. What is m here? Y is the output. X is the input.
M is
what we
coefficient.
call as
Slope.
slope. Yes. C is what we call as
Constant.
coefficient. Constant also you can call, or I would write it as intercept. Intercept of the line. Okay, this is what we call as the very basic equation of a straight line. Okay, now going ahead, what I want to do is I want to put a line here. Now see, there can be multiple lines. The line can be here also, up also, down also, whatever it is, but I want to find the best fit line wherein I need to find the value of m and I need to find the value of c. Okay, because I know the value of y, I know the value of x. If I find the value of m and c, I will get the equation of a line and I can plot that. That is what linear regression does. As simple as that. That is what it does. It finds the best fit line. Once you get the best fit line, you can get the predictive analysis output for anything. How do we find this best fit line? So in Scikit-Learn, it uses a concept called as least square method. Okay, this is the method name. Least square method or least ordinary square is what we call. Okay, so this method actually gives us a formula to find the value of m. That's it. What it does is it uses a formula of m. If you find the value of m, which is slope, you can obviously find the value of c because you know what is y, you know what is x, right? It's all simple linear algebra. With the help of that, you will be able to kind of find the value. If you find one value, another value is very simple to find. Correct? Now, what does least square method actually indicate? So let's go back to our Scikit-Learn. One important point what I want to tell you is whenever you're learning anything in machine learning, always refer the original site. Let's go to regression here. In regression, I spoke about ordinary least square. Let's go inside that. And you'll have here linear regression part also mentioned. In this linear regression part, it says that we can find the best value of coefficient. Okay, see, for now I have got only one input. That is why only one coefficient will be there. Only one slope will be there. If you have multiple inputs, multiple values can be considered. Okay, and intercept also I will find here with respect to this. It says that it uses ordinary least square. What is the formula of ordinary least square? If you want to find the formula of ordinary least square, I think so it's mentioned here, ordinary least square. With the help of SciPy you can find. You can just Google what is the formula of ordinary least square. So let's Google here. Ordinary least square formula. Okay, I'll just show you the simplest one. There might be a lot of variants for the same, but yeah, this is the simplest formula of ordinary least square. With the help of this itself, you find the value of m. This might look complicated, but it is not. It is very simple. What does it say? It says whatever the value of x you have taken. First of all, there are two parts for it. One is numerator and one more is denominator. In the numerator, you take the first value of x, subtract it with the mean value of x. So whatever the value of x you have, take the mean value of it, average, multiply it with y, and then subtract it with the mean value of y, divided by the same x minus x dash. X dash is average value, and then take the whole square of it. That's it. This is the formula what we have. We don't have to implement this mathematically, not required, because it can happen on its own in the backend. Just for the sake of understanding, if you want to understand what is the maths which is happening behind it, this is the formula which is considered. Ordinary least square formula is considered here. What we'll do now is we will apply the concept of this linear regression, and let's see whether we are getting the value of m and the value of c or not. See, the best way to apply any algorithm using Scikit-Learn is to go to its website and see the examples. See here in examples, what is there? I'll exactly mention the same thing. Okay. Here and there, simple modification will be there. But again, I'll mention the simple part itself. What I'll do first is import numpy. Now see why they're importing numpy, because they want to mention the value of x and y. But we have already mentioned the value of x and y, correct? So we don't need that. I will not import numpy. What should I import? I'll import the library scikit-learn. Copy and paste it here. I'll just run this. I've imported linear regression part. Fine. The next thing is x value is already available with me here. I have not mentioned it. Let me mention what exactly is the value of x. So the value of x, what I want to consider is the first column, correct? df of years of experience. Can I write here df of years of experience as my column of x? Okay, if you run this x, you'll be able to see the value, whatever I have is the value of x. If I have to convert it into numpy array, I can just write it as dot values. I will get numpy array here. Always remember, it's better to have numpy arrays to work with the machine learning part. So numpy array value 1.1, 1.3, 1.5, whatever it is. How many values you have, if in case you want to find here, right? You can just mention df.shape and check. Totally, there are 30 rows and 2 columns. That is what you get to see. Okay. What I'll do now is, see, there are 30 values of x. Same thing for y I have to mention, right? Can I write y is equal to df of salary dot values? And if in case you want to check what is there, all the values are mentioned here. X is given, y is also given. I'll just put it in one go. And I'll just pass it to you. I hope till here everything is clear. I've taken x, I've taken y. Let's go back and check in the example what it is doing next. So x is taken, y is taken. Yes.
So in the y only decimal point, after the decimal point, the value is not shown.
That's okay. It's actually because the value is .0. So basically salary is 39343.00. It is taking by default into floating point. Okay. So it's okay. It doesn't matter.
Okay.
Fine. The next thing is y value is already given. So I'll not do anything with y. I will take reg now. This particular part. Reg. Copy as it is. No difference. Copy as it is. Now the value of x I have given here in terms of smaller case. Okay, so I'll just change this and then I'll run this. Now when I run, I get a small error. Let's try to understand what is this error. See, we learn when we get a lot of errors as well, right? We learn from errors as well. What it says is, this error says that your input, whatever you have, right, it should be in 2 dimensions. If you scroll down and if you check for error, see here it says value error expected 2D array. 2D array means it should be in the form of matrix, but it has got 1D array. 1D array means it has come in the form of vector. Now the best part here is Scikit-Learn actually tells you what you need to do. So it tells you use this particular method to change your data from vector, convert it into matrix by writing dot reshape of -1, 1. So just copy this dot reshape of -1, 1 above here, where you will have to copy here for input. Only for X it is creating problem, not for Y. That's it. One single line. Just put here reshape -1, 1. What it means is how much ever rows, how much ever values are there, right? All of them will be considered as specific row, and there will be one single column. So there will be 30 rows and one single column. That is the indication of this -1, 1. Rerun this cell again. How do you rerun? Shift enter again, shift enter again. That's it. There won't be any error. And your problem is now solved. You're done. You're done with respect to this. So please write here reshape of -1, 1. Why do you need this? Because by default, if you have only one column, it will take one dimension. But Scikit-Learn wants you to have 2 dimension. Okay. So note here, input should be always in 2 dimension. If it is in 1 dimension, convert it. With the help of this, you will be able to convert it very easily. Now you are done. You
Sir,
can.
I have a question here.
Yes, yes.
Generally, suppose we have 2 values, 2 columns are there.
Then you don't have to do anything.
Okay. If X has 2 columns and Y, suppose there are 3 columns, 2 columns for the independent variable and 1 column is for the dependent variable.
Okay.
How it will be fit in X?
So that is what we call as multilinear regression. You can't visualize that. It is called as multilinear regression. You will have multiple slopes. You'll have M1, M2, M3. The equation now will not be y is equal to mx plus c. It will be y is equal to M1, X1. X1 will be the first input. M2, X2. M2 will be for the second one. X2 will be the second input. Got it? How much ever inputs you have, that much. The line will change. The value, the equation of the line will change now.
Then this linear regression function will work. Yeah,
Definitely it will work.
Then we have to go for any other regression function.
Not necessary. You will have to check if it is linear or not. One by one, take the input and check with the output, is it linear or not? If it is linear, then you go ahead with linear regression. If it is not linear, for example, consider that there are 3 columns. 2 columns are linear. Okay, you can see with the help of visualization. One column, let's say it is non-linear. It is having some other property. That is when you apply the concept of polynomial regression only on that column. Only for that column, you apply polynomial regression. So when you are applying polynomial regression, the degree will change. You'll have the concept of degree there. I know it's a slight complex part, but I'm just trying to help you understand what will happen. You'll have to go ahead with polynomial regression then.
Okay. Sir, my last question is, suppose X, Y, and Z. Z is the output. Then we can apply 2 times. Suppose we have a linear regression relationship. Then we have to apply 2 times linear regression with X plus Z and Y with Z. Am I right?
You don't have to apply 2 times. That is what is called as multilinear regression. Apply only once.
Okay. So one variable, one independent variable, and one output variable.
Yes. In independent variable, you might have multiple values. For example, we know that salary is not only dependent on years of experience. This model, whatever we are building, we might not build it for the final production model, because we know that salary is not only dependent on years of experience. It is also dependent on what qualifications you have, what certifications you have, right? Additional columns will come into picture. So all of those additional columns you will have to add in here. The idea is still the same. The logic is still the same. But then the equation will change. Instead of mx plus c, it will be m1x1 plus m2x2 plus m3x3. Multiple slopes will be there for that.
Okay, sir. Okay, sir. Thank you.
Got it. Yeah. Fine. Now we have fit our model. Fit means we train. Basically, fit means train or mapping input with output. So whatever input values we have, we map it with output. That is what is called as fitting the model. Once that is done, you can now go ahead and find the coefficients. So if you remember, I had mentioned that coefficients can be found out here. So if you go back and check here, there is something called as reg.coef. I'll just write here print reg.coef and print of let's say reg.intercept. Both the things I'm mentioning here. Now this coefficient is nothing but my slope. Intercept is nothing but my intercept. Fine. When I run this, I get the equation of a line. See, my coefficient is this, my intercept is this. Can I write my equation of the line to be y is equal to 9449.96 x plus 25792.2. This is the equation of my line. So I wanted to find the value of m and c. Just one single line in Scikit-Learn does the task for you. Right? That's the output, what you get. Now, if someone asks me, let's say that there is a person I want to predict. Okay, I want
Excuse
to
me, sir.
predict. Yes.
Sir, in this line 11, sir, you run the regression is equal to linear regression, sir. What will be the output variables, sir, like coefficient, intercept, and what any other variables, sir, that will get output?
So
Apart from the coefficient
you will
intercept.
get totally 4 returns here, 4 to 5 returns. If you can see here in this documentation, the first return what you get is coefficient, then you get rank, then you get singular, then you get intercept, then you get n features, feature names. But what is important for us is this two variables, right? Coefficient and intercept. That is what I've shown you. Okay.
Okay, sir. Thank you, sir.
Yes. You get a lot of different variables as the outputs here. You can actually consider by writing reg.rank, reg.singular, reg.n features, but they are not important for us right now. For us, what is important? Coefficient and intercept. That is what is considered here. Fine. Okay. What if I want to predict now for a person who has got, let's say, 3.2 years of experience? How do I predict? Very simple. Y is equal to mx plus c. Use this equation itself. Okay. And instead of writing x, what you need to write here? Write here 3.2. The output what you get is 56,032. So the salary will be 56,032 if someone has got 3.2 years of experience. My model says this. That's it. As simple as that. If in case you want to use the Scikit-Learn terminology for doing this, Scikit-Learn has got something called as predict. So you can write here the exact same thing like this. Instead of mentioning 3,5, what should I mention here? I should mention here 3.2. Okay, same thing. I'll get the exact same result. Okay, I have not imported numpy here. I'll import numpy as np. I'll get the exact same result. What is happening mathematically? Equation of a straight line. Y is equal to mx plus c.
Hello.
Yes.
Sir, why are you putting two brackets in
if you remember, I had told you input should be always in 2 dimension.
Sir,
if you keep input in 1 dimension, you get an error. Same error. Expected 2D array.
Okay. Suppose the input is an array, then again we have to reshape it for 2 dimensions.
You don't have to resave it. You just have to rerun it.
My question is, suppose I created an array of unknown data with the help of numpy and have given the name of the array in this predict. Okay. And that array is of.
You will have to reshape it. Correct.
Reshape
you will
it.
Have to reshape.
Oh,
yes.
Okay, sir.
Definitely. So if you have multiple values to be predicted, you'll have to reshape it and you'll have to run it. Same thing. So this is the note which you need to remember. Input should always be in 2 dimension. Okay, now for the final part.
Excuse me, sir. Can we give other than this numpy array? Can we use ordinary arrays?
We can use anything. You don't have to necessarily give this particular part. For example, if I write list also here, this will also work. But the point is, it should be in 2 dimension. If you give 1 dimension, you will get an error. That's it. Got the idea? It should be in 2 dimension. It doesn't matter what you give. It should be in 2 dimension. Whatever you want to do, you do, but it should be in 2 dimension.
This is the major problem most of the time it is creating. Generally, we give the one-dimensional and it creates the reshape problem.
Correct. No, see, this is only in linear regression, simple linear regression. When you're doing multilinear regression, right, you will give 2 values, and we are giving 2 values, right? It will eventually get itself converted into 2 dimension.
Okay.
But yeah, that's the base which you'll have to remember. There are certain syntaxes.
Okay, sir.
Yes. Okay, now for the final part, what I'll do is, I'll just take back again the matplotlib part. Okay, and I want to put the best fit line also here. Fine. So what I'll do here is I'll write pred. Pred means for whatever the value of x I have, I will actually predict the value. So can I write here reg.predict, okay, of directly x. Now see, I know x is already in 2 dimensions, so I'm not converting it. Okay. All the values I'll get it in pred here. Now, if I run this separately, I think so it will give you much more clarity. So let's say that I run this pred separately. So see, this is my predicted value. Where is my actual value? My actual value we have seen here already, right? 39343. So you can see here 39343 is quite near to 36187. I know there is some amount of error, but again it is somewhere similar. Okay, again 38077 is what we have got here. Here what you can see, it is 46. Okay, I think so this is huge. The third one is 37731. 37731 is near to 399967. So you can see here some values are nearby, some values are far. This is the best optimized solution what you are getting right now. Okay, what we will do is we will plot this particular thing also on a graph. Okay, I want to plot this also on a graph. So I will take the same x-axis, but instead of y-axis being the original salary, I will take the predicted salary. So I can write here pred. Fine, and I can run this. I don't want scatter, I want normal line. So I'll write here plot. I'll give you a different color. Let me write, let's say C is equal to R, color red color. Can you see here what is happening? This particular line is actually passing through multiple points in such a way that it is actually giving me the minimum error possible. Okay, it is trying to pass through each and every point. Yeah, the best fit line is what we call here. So see, originally I had only points. Now I have got the best fit line here along with the points. What is the equation of a line? I have already told you. This is the equation of the line. That's it. That is the concept of linear regression. If you have any queries in linear regression, you can please ask me, or else now we'll move on to the next algorithm.
Sir, just last one.
I couldn't hear you. Can you repeat again?
Repeat again.
Yes. So what I've done here is, whatever the value of x I have considered, the input values, I am predicting it with my machine learning model. So I write here reg.predict. So this is what my machine learning model is actually trying to tell. It is not the original value. It is the predicted value, which are similar to the original values. And that is what you can see here. So you can see here the best fit line being considered. The best fit line, how did I get it? Because I got this with the help of linear regression, and I know that linear regression equation is a straight line. So linear regression equation also I have got, and I have got all the points also with respect to x and y. So instead of writing here df of salary, which is my original salary, I'll put here pred. Pred means what? The predicted value, the predicted salary. The x-axis is still the same. Independent value is still the same. The dependent value is what my predicted value is. That is what I have plotted here. I get a straight line. That's it. That is what I have shown you here. Yes.
Can you draw a scatter plot for this prediction also, sir?
We can draw scatter plot, but scatter plot doesn't make sense. It will be like a straight line. So see here, this is how you get scatter plot.
Okay, sir, almost same.
Yeah, it's a straight line. Basically, all the points will be on the straight line. So the idea of linear regression is to put each and every point on one specific line. That's the idea. Okay, what we'll do now is we can now go for the second algorithm, which I want to discuss in predictive analytics. We have discussed now regression, simple linear regression. Now see, there are different variants of regression models also. We have got multilinear regression. If in case you have got multiple, let's say, columns to be considered as input, we call it as multilinear regression. And in that, you can also go ahead with polynomial regression, because you might have certain non-linear properties being considered. So polynomial regression might be considered with regards to that. Apart from that, more complex models can actually consider working with respect to regularized regression. We have got something called as ridge, lasso, and elastic net. These are all the complex models which are actually available. So basically, this particular model, what it does is it actually adds the concept of making your model much better. Okay, for example, if you have multiple columns to be considered and each and everything has have got different properties, right? You can actually go ahead with the more complex models. There are lots of algorithms which are available. Okay, but I just wanted to give you a simple overview on this, and I'm opening the doorstep for you to explore different algorithms. Okay, let's go ahead with classification now. What is classification? Very simple. Classification means the output, whatever I have, it will be in the form of discrete value. Discrete means it will be categorical, either 1 or 0, or it will be true or false, this or that. Okay, you know the number of output categories what you have. That is when classification is applied. As simple as that. In classification, we have got mostly two different types of values, or two different types. One is binary and the second one is multi-classification. As the name suggests, binary means you'll have two categories. Either it will be 0 or 1. Either it will be apple or mango. Either a person is wearing mask or a person is not wearing mask. How about multi-classification? You'll have a couple of additional categories added. You will have 0 or 1 or 2, or you will have, let's say, apple or banana or mango. This is what we call as multi-classification part. I'll show you a very simple example of multi-classification before going ahead. There's a unique website which is called as keras.js. So Keras is actually a library in Python, which is used for building deep learning models, one of the variant in machine learning itself. I want to give you this particular site also. So what it does is, it has got a canvas. Okay, this is actually a multi-classification model. It has got a canvas. You can draw here any digit from 0 to 9. Only one digit you are able to draw. Okay, and when you draw that digit, right, that machine will recognize which digit is it. So see, for a human being to understand what digit is it, it's very simple, because we have gone through that particular procedure of training, that this is 1, this is 2, this is 3, this is 0, whatever it is, right? Lots of images have been considered in our head. But then if you want to do the same thing with a machine, if you want machine to recognize that particular thing, the same procedure is followed. It is treated with a lot of images, trained with that, and then now you are inferring. Okay, you are actually checking the output, the prediction stage. The predictive analytics is considered. If I write here, let's say 0, you'll be able to see that the output what you are getting here is in the form of, the highest value. It actually tells us the probability. Okay, this is the highest one. So machine is able to recognize that this is 0. How about next one? If I write 1 here, you can see that it is coming 1. If I write, let's say 2, you'll be able to see that it is showing 2. I'll write here a little complicated model. Let's say I write here 3, but it should look like 8. Okay, wait, let's see. Okay, so I think so it got changed suddenly like this. How about writing Okay, I think so. Yeah, can you see here what is happening? I have written a little complex model. It is not able to recognize what is this. That is why you are able to see 3-4 different variants, right? It says 8, it says 2, it says 3. The probability is varying here. So the point what you need to note here is, in classification, you get the output in the form of probability. Whichever is the highest probability, that is the output which is considered. Okay. So it doesn't tell you exactly that 100% this is the result. No. For example, consider an example that there's a small baby, and that small baby is actually trying to understand what is happening in the world, right? So let's say that you have thought that baby only two things, cat and dog, only to differentiate cat and dog, no third animal. What if you get goat in front of that particular baby? That baby would likely to tell that this is more of a dog than a cat, because goat looks somewhat like a dog, more of a dog than a cat, right? Maybe, whatever properties, it is big and it has got some different strong legs and all the other things, whatever it is, right? So the point what I'm trying to tell is, the machines learn in terms of probability. It actually gives us the output in terms of probability. If I ask you, if I toss a coin, what is the probability that the coin, whatever you get, will be head? 50% probability, right? What is the probability that you will get tail? 50% probability, right? So that probability is actually considered as the output, and whichever has got the highest probability, that is the output what we consider. This is a quick overview of classification part. We are going to again use the machine learning for the consideration of classification part. In classification, there are multiple algorithms again. There are multiple algorithms, but we are going to use one very important, one very popular algorithm, which is what we call as decision tree. So if you are from the, yes.
Sir, in keras.js, we have ready-made models, many ready-made models are available. Can we use it there, like ResNet 50, Inception V3? So in future, we can use keras.js.
So keras.js is just a place for inference. That means it is just used for prediction part. It doesn't do anything with respect to training. If you want to train the model with respect to, let's say, ResNet or Inception, you'll have to use the base keras library for that.
Okay, sir.
You'll have to use it in Python. This one is just for you for the demonstration purpose.
Demonstration.
You can't train here.
Okay, sir.
There is no training happening here. It is just the demonstration purpose. Already it is trained. For example, if you consider here, basic CNN architecture is already trained here. You are just seeing the output. If you want to use it for your project, or maybe you're not doing anything else, you will have to use the base keras model. So if you go to keras, you have got here something called as applications part. So in keras application, you can just load this and you'll be able to see all the models are available. VGG16, Exception, ResNet 50, all the models are available. You can load it. And it also tells you how to load the model. For example, if you want to load ResNet, load it like this. And then you can go ahead and play around with it.
Okay, sir. Thank you.
Yes. Fine. Let's go ahead with decision tree classifier now. If you are having a little base in programming part, you must have definitely heard about decision tree. So it's a very simple understanding. It's one of the intuitive algorithm which we have in machine learning. So decision tree means you are actually creating a tree with respect to specific decisions, and you are creating branch of that particular tree. So you start from one specific node and you reach the final node. So the starting node is what we call as root node. So root is where the tree starts to build, and the final node what we have is called as leaf node. That is where the end product what we get, right? So we will again use a data set for the same, and then we are going to again do the analysis on it. So let's go back to Kaggle, and I'll give you another data set. It's called as social network ads. So I'll give you this data set. You can please consider downloading it again. It's of, I think so, how much? 4.9 KB. So I'll just send you the link.
Sir, excuse me, sir.
Yes.
When we're dealing with the credit card fraud action cases,
Mm-hmm.
so that means the transaction is fraud or non-fraud.
Correct.
So again, it is into the term of probability, or it is the exactness. Yeah, this is fraud or this is not in the term of
So there are two
classification.
ways to look at this particular problem, credit card fraud detection. Either you can go ahead with the classification technique with the help of probability, or else we have got something called as outlier detection. So all are normal except for few things. So what are those few things wherein fraud has happened? See, normally when you talk about credit card fraud, is it frequent? It is not frequent, right? It happens very rarely. So if you see the data set, you will have a highly imbalanced data set in that. So you can either go ahead with classification part and consider working with respect to probability, or else there is another part which is what we call as the anomaly detection. Okay, anomaly detection or outlier detection. So that technique we can actually use it, and we can find the different value. Like the normal track is that everything should be normal. If there is some abnormal thing which is happening, then you go ahead and you apply that particular part. Okay, two ways of dealing with that. Yeah, fine. So I've given you the dataset link. Please do consider downloading this. How to save it in Jupyter? So see, Mariam, you don't have to do anything to save it in Jupyter. If you write the code, right, it gets auto saved, or else just go to file and click on save. That's it. If you want to upload the data set here, you'll have to click on upload, and whatever you have downloaded, right, just consider uploading here. That's it. I'll just rename this 5. I'll remove, I think so I've downloaded it multiple times. Social network ads.csv is what I've downloaded. I hope you're getting that. Okay, do it till here. I'll give you a minute.
పని నిమిషాలు అయిపోతుంది తినేస్తాం అప్పుడు తింటావా తినేస్తా
Okay, is it done? We'll go ahead now and we will see how to apply the decision tree part here. I'll create a new Python environment again. Let's first try to understand how do we go ahead with respect to this problem statement. I'll write here decision tree classifier. Import pandas as PD. df is equal to pd dot read underscore csv of let me check what is it. It is social network ads. And now again df dot head. So there you go. You are getting this particular thing as the output. There are 3 columns. We have got age, we have got estimated salary, and we have got purchased. Now, what exactly is this data set all about? It actually speaks about whether a person who is so and so age and who is having, let's say, the estimated salary of so and so, whether that particular person has purchased a product or not. Okay, that is the clarity what you get. So, a person who is having so and so age and who is having so and so salary, whether that particular person is purchasing that particular product or not. That is the criteria what we are checking. Age, if you want to check, you can just write here, let's say df.shape. First of all, let's try to understand how many values we have. Totally, there are 400 values. That is what you get to see. Okay. If I write here, let's say df.describe, it actually talks about the minimum value. So the minimum age what we have is 18. Okay, someone is as small as 18 and someone is as big as 60. So the highest age is 60. the minimum salary what someone is receiving, an individual is receiving is 15,000, and the highest one is 1.5 lakhs. That is what you get to see. Okay. I think so. Rest all are not so important, not so critical right now. The mean age group, if in case you want to check, it is 37, and then the mean salary is 69. Okay, yeah, this is fine. Let's see how many people have purchased the product and how many people have not purchased the product. How do you see that? So, for example, if I take df of purchased, and if I write here dot unique, you'll be able to see the values are either 0 or 1. But what if you want to know how many people have purchased and how many people have not purchased? You'll have to change it to value counts. You'll be able to see that out of 400 people, 257 people have not purchased the product and 143 people have purchased the product. That is what you get to see from this particular data, right? I think so. This is fairly simple for us to understand what we have done. I'll just send you the code till now, whatever is considered. If any line, any confusion, please let me know. I will help you out.
Sir, how to download the data, sir? Again, we are not able to download the data from the Kaggle.
Same thing, how you have downloaded the first data, you will have to download it like this. Go to this particular link, click on download option. If it asks you for signing in, I think so only one time it will ask you for signing in, not always. So once you download it, you will get the CSV file. Don't download using this particular button, download it with a small button. So when you go to this particular link, right, you will find here, scroll down, you will find here small download option. Just click on download.
Okay, so thank you, sir.
Okay, yeah. Okay, now what I'll do is I'll make a small analysis here with respect to visualization. I want to bifurcate my data with respect to people who have purchased the product and people who have not purchased the product. For example, if I import matplotlib.pyplot as, let's say, plt, and if I write here, let's say plt.scatter, df of, let's say if I take age on x-axis, okay, and df of estimated salary on y-axis, and if I plot a graph, so see here the output what I get is all the points considered here, right? But then I don't know amongst this who are the people who have purchased the product and who are the people who have not purchased the product. I don't know. How do I know that particular thing? So for that, I will have to bifurcate the scatter plot into two variants. One is where the value of column purchased is equal to 1, and second is where the column of purchased is equal to 0. Okay, so how do we do that? What I'll do here is I'll write here df of purchased. The df of purchased, it should be equal to 1. Okay, what it should be equal to 1. So I can write here df of purchased of this particular thing. So I get one data frame, a small sub data frame consisting of 143 values, wherein the purchased value is 1. I can put this inside purchased data frame variable. Second thing, I will write not purchased np data frame. What should I change here? Instead of 1, it will be 0. Do you understand this? Very simple. So wherever purchased value is 1, there I will consider pdf as my data frame name. Wherever purchased value is 0, I will consider not purchased np. Okay, now I will plot the same graph again, but I will bifurcate it now. I can easily bifurcate it. Instead of writing df, I'll write here pdf. Another scatter plot will be npdf and npdf. So when I do this, right, what will happen is the output what I get will be bifurcated. That means these people are the ones who have not purchased your product. These people are the ones who have purchased your product. Okay, very simple. So I have bifurcated this particular thing with respect to condition. If you have learned about conditions in pandas, then you would be able to understand this very easily. I'm just saying that the column should be equal to 1, the column should be equal to 0. That time, wherever the column is equal to 1, for that age and estimated salary, I'm plotting a graph. When column purchase is equal to 0, for that age and salary, I'm plotting a graph. Okay, clear? What we need to do now is we need to bifurcate this particular thing in such a way that it gives us a boundary. Okay, it gives us a boundary. It should give us a boundary that this boundary belongs to the people who have purchased. On the other hand, it belongs to a boundary to the people who have not purchased the product. We need to create that boundary. So the end result of any classification technique is to create boundaries. Now, boundaries can be created in different ways. It can be a straight line, or it can be a circle, or it can be, let's say, horizontal lines and vertical lines, whatever it is. Trees, decision tree, boundary will be in such a way that you get the output in the form of horizontal and vertical lines. Let's talk a little bit about decision tree here with respect to Scikit-Learn library itself. I think so Scikit-Learn, this is done. I'll go back to the API here. Scroll down, you will find here decision trees. See here, decision tree, we need classification. So decision tree classifier, I will go here. I am sending you the code again. So I'm sending you the link. You can just cross verify. Okay, what does this decision tree actually tell? So decision tree classifier tells us that it will create a neat and clean decision tree with respect to its criteria. Okay, there are different criteria. We have got something called as Gini or entropy or log loss. Now, I don't have time to go into deeper understanding about this, but what you can understand here is it is the function which is used to measure how you are splitting your data. For example, let me first show you how a decision tree actually looks like. So decision tree, this is how it looks like. Let me consider here. Yeah. This is how a decision tree looks like. Decision tree is actually an inverted tree. That means root will not be down, it will be up here. Okay, root node, and then you will actually split this particular thing with respect to one criteria. Okay, there will be certain conditions which will be considered based upon which it will split. Whenever you are splitting, you call the other nodes as decision nodes. Can you see your decision node, decision node? The final node at the end, after that, wherein you can't further split, that is what we call as leaf node. So you can see here there are 1, 2, 3, 4, 5 leaf nodes here. And the top one, there is only one root node. There will be multiple leaf nodes, and the nodes which are in between leaf and node is what we call as decision nodes. Okay, this is what we have got here. The depth of the tree is determined from root to the leaf. The highest leaf and the root, whatever we have, the maximum depth is considered with respect to that. Okay, so decision tree actually works on the consideration of what exactly is the best criteria to split. Okay, that's it. Based upon that, it gets split, and then the strategies will be considered, how exactly it will be taken into consideration. So what we will do is we will apply directly this decision tree, and then we will see the output. Okay, I'm going to use the exact same thing what is mentioned here. Okay, and we are going to see what output do we get here. Fine. So okay, now before going ahead, I want to bring one more data or one more point into consideration. Whenever you are dealing with machine learning, right, you will have data. That data, you will have to specify it into input, which is X, and output, which is Y. That X and Y, you can further split it into training data, which is what we call as X train, and testing data, which is what we call as X test. Same thing with Y train and Y test. Now, what exactly are these four things? Let's try to understand. So whenever you are creating a machine learning model, or let's forget about machine learning, let's talk about a very simple general scenario. Whenever we as teachers, we teach something in class, that is the training phase, right? There we tell the question and we tell the answer as well. That is what we call as X train and Y train. In the training phase, I give my input as well as my output. I teach the students, I teach the participants the input as well as output. For example, if I'm teaching mathematics, I'll tell 1 is my first input, 2 is my second output. The output what I get is 3. Similarly, 4 is my first input, 5 is my second output. The output what I get is 9. I am telling input as well as output. But then in the exam phase, I give only the question, I give only the input, and I'm expecting output to come in from the user, from the student, correct? So I give only the X test value and I get the predicted output. That predicted output I will cross verify with Y test. Got it? So it's always important that you split your data into train and test. In linear regression, I didn't split my data into train and test because my data set was very small. Whatever training I have considered, the same thing I have considered for testing as well. But that's not likely the case always. What you will do, you will split your data into training and testing, which is what I'm going to do right now. Okay, so if I have to split my data into training and testing, I can just go ahead and I can use something called as train test split in Scikit-Learn. What I have to use? Train test split in Scikit-Learn. So I will go ahead and I will use this train test split part to split my data. Okay, it splits my data into train and test. I will so when you go to examples, right, please click on hide the prompt so that you don't get this embarrassing greater than symbol like shell what you get. So I don't want numpy. I'll just copy the scikit-learn model selection part. Done. And then from down, I will select xtrain, xtest, ytrain, ytest. Here, xtrain, I'll make everything small so that it's easier for me. Xtrain, xtest, ytrain, ytest. I'm splitting this particular thing. See, X is split into X train and X test. Y is split into Y train and Y test. Okay, it is split. But how is it split? There are totally 400 points. Which one will go to train? Which one will go to test? I am taking randomly, but I am controlling the randomness with the help of random state. Which means when I maintain here one specific value, let's say 42. 42 is just one value by default which is given. If I maintain 42, then my training data and your training data will be same. Okay, that is it. Although it will be in random, we don't know which point will go where, but then the seed of the randomization will be set there. Okay, so the idea is here random state makes sure that we control the randomness. My data will be equal to your data. We can cross verify it. But then how much data will go into train, how much data will go into test? We are specifying here test size as 33%, which means train size will be 67%. Okay, let's run this and let's do the simple calculation. If I write 33, okay, I have not given here what is X. So I'll have to write here X is equal to df of, what is it? Age, comma, estimated salary, dot values. Fine. Dot values means convert it into numpy. Now I don't have to convert it into 2 dimension because it's already in 2 dimension. There are 2 columns, 2 dimension, it's already there. df of purchased is my y value. Now this will work. Okay, it is split. 33% with respect to 400 will be how much? 132. On the other hand, the opposite will be 67, right? So complementary, if I have to take 67 with respect to 400, it will be 268. When you add, you will get 400 totally. So when I write here, let's say print of X, let's say length of X train, training data, how much I'm just checking, and then length of Y train, you will get the same thing. Sorry, X test. will get exact same thing what I have stated. 268 and 132, training and testing. Okay, I'm giving you this particular code. Any confusion, please let me know. I'll help you out. I hope you are able to understand this till here. Fine, we have split our data. Now it's time to apply decision tree classifier. Decision tree classifier we apply for training data and we validate for test data. We predict the output for test data. Okay. So how do I apply decision tree? Go back to this and see here. I don't need cross validation. I need this decision tree. Just go ahead, apply decision tree classifier here. Okay. Then I need the CLF part wherein I'm calling for decision tree classifier. Okay. And then I don't need anything for cross validation score and all. Now the next code, whatever it is, I will write it. So very simple. What we have done with linear regression, same thing we will do it here. See, in linear regression, what did I do? I have written here dot fit. So here also I'll write dot fit. Instead of writing X, now my X is split into two variants. Can someone tell me what should I write in fit? See, previously I had written X comma Y, but now my X is split into X train and X test. What should I write here in fit?
X training, sir. X train.
X train comma X is for input. With fit in supervised learning, X and Y both should come. So here it will be Y train.
Y train.
Yes. See here the change what I have done, X train and Y train. This is what I will run here. Okay. Once I run this, all set. I can now go ahead and I can consider the prediction. Obviously here I will not have coefficient and intercept. Here directly I can go ahead and predict. I'll write here, let's say Y pred is equal to model dot predict. Sorry, not model. I've written CLF here, right? CLF dot predict. I will take now X test into consideration. My input is now X test. Let me check. I'm getting somewhat whatever the output is required. I will cross check with respect to Y test now. Can you see here the difference what we are doing? Let me explain step by step. See here, I am take training input and training output. So this is my training stage. I am in the classroom. I am teaching the students. I am teaching the students the questions. Okay. Along with questions, I am also telling them the answer. Now, this is the testing phase. This is the testing phase. Use input test. Okay. For prediction. And get predicted output. Now, what are we getting? We are getting the predicted output. So consider like this. I have got totally, let's say 132 questions in the examination. Totally, I have got 400 questions. In that 400 questions, it's only true or false. Okay. 268 questions, I have done it in my classroom session. 268 questions, I have told, is it correct? Is it false? Whatever it is. Now people have understood, students have understood the pattern, and in the examination, they have given their answer. Okay, this is the answer what one specific student has given. Okay, so it is 110 true or false, whatever it is. Okay, I have to cross verify. So this is my cheat sheet. I have to cross verify, right, whether this person has given correct answers or not. You can see here some answers will be correct, some answers will be wrong. You can see here the first answer should have been wrong, but the answer what student has given is correct. Or let's say in machine learning terminology, the answer should have been not purchased, but the machine learning model is saying that it is purchasing. First answer is wrong. Second answer is absolutely correct. Third answer is also correct. It is 0 here also, here also. So if it is matching, right, it is correct. If it is not matching, it is not correct. What we can do is we can cross verify this particular thing with the help of metrics. I can call here from Scikit-Learn .metrics import confusion matrix. There is something called as confusion matrix, with the help of which you will be able to understand how many values are correct, how many values are wrong. So I can write here y test, which is the correct value, and y pred, which is the predicted value. You can see here out of 132, 71 values are correctly predicted as not purchased. 42 values are correctly predicted as purchased. 10 values are wrongly predicted as purchased, and 9 values are wrongly predicted as not purchased. So the diagonal value, what you see, 71 and 42, these are the true values. And the left diagonal, the other diagonal, what you see are the false values. Got the idea? This is the true value. How many values are truly predicted? If you count, if you cross verify, right, this is the end result what you are going to get. And from this itself, you can check the accuracy, which is one metric for classification, to understand how accurate your model is. You can just consider adding here the true value 71 plus 42 divided by the total value 71 plus 9 plus 10 plus 42. I think so it is 132, whatever it is. So you are getting 85% accuracy. That means out of 100 values, 15 values will give you wrong result, which is not bad. Accuracy, if you are getting 85, I wouldn't say that it is a bad this one. You can, without doing this, if in case you want to check accuracy score, you can just write your accuracy score of y test comma y pred. You will get the exact same value. Mathematically, I was just trying to show you, but then that is what you get at the end. So these were the different stages which we have used in classification part. The first stage was, I'll just write down here all of the steps name. So first step was data ingestion. Step 1 is what we call data ingestion. We get the data and we try to create a structured format for it. The next part, wherein we are trying to analyze all of this particular thing, this is what we call as pre-processing part, EDA part, or pre-processing. If in case you want to do some kind of pre-processing here, you can do here. The next part, what we have is step 3, taking X and Y and splitting the data into train and test. Okay, this is step 3. Step 4 is applying algorithm. Step 4, applying algorithm. Step 5 is prediction stage. Step 5, prediction, and then the final step would be evaluation. Step 6 would be evaluation. So you are evaluating whether your model is performing well or not. Now there are a lot of different evaluation techniques. Accuracy is just one amongst them. We have got precision, recall, AUC curve, ROC curve. A lot of different things are actually available. But just for the basic part, I have told you this particular thing. That concludes our session on classification. If you have any queries, now you can please ask me. If you didn't understand any specific line, right, please feel free to ask me. I can probably help you out with that.
Sir, can you share both the Jupyter notebook to us?
I will be sharing it with Pankaj sir, and I think so later on you will get an email with regards to this. I'll share all of these 4 files.
Okay, sir. Okay, sir.
Okay, yeah. Okay, anyone else? Any other query?
Sir, if any data change happens, so this will automatically take it all the corrections later? I mean, if the raw data,
So
if there is
if there is any change in data, then you will have to actually go for advanced level part, wherein you will have to consider the DevOps tool chain. So what would happen is continuously you will have to integrate it and then you'll have to deploy it back again. So you'll have to retrain your model, correcting the errors and make a better model out of it. What we are seeing right now is the very base. Okay, but we are not doing any additional component part. As you had mentioned, if there is any change in data, obviously the change in data will come when probably you're considering, let's say, streaming data, or you're taking data which is continuously being sent to one specific value. So that time you will have to integrate it with little complex level techniques. The idea is still the same. You'll still build a decision tree classifier or whatever algorithm you're building, but then since your data is changing, it has to be side by side getting integrated to the original data set, and then it has to go through the same pipeline what we have created, and then the machine learning model has to be designed. So there is a concept of software methodology which comes into picture here. The concept of DevOps will come into picture there then.
Okay. Thank you.
Yeah.
Sir, what will DevOps do here, sir?
I couldn't get your question. Can you come again?
Sir, what is to do with the DevOps in this, sir?
So see, DevOps is actually used for production level project. See, what exactly is DevOps? DevOps actually is one specific set of practices which combines the software development with IT operations. That is what we call as development operations, right? If in case you want to take this particular model in a real life scenario, and maybe that time the model is continuously changing, the data is continuously changing as asked by Srinivasa sir previously, right? So that time what would happen is when you are putting this particular thing onto the DevOps toolkit, you will continuously take the data. You will actually implement something called a CI/CD. It's called as continuously integration and continuously deployment. You integrate the data, you run the machine learning algorithm, you deploy it. Okay, and that is what is happening in the real world scenario with respect to that. I hope I was able to give you some clarity with regards to that, Gajendra.
Yes, thank you, sir. Yes, yes. Can we get your contact mail ID, sir?
Sure. So I'll be sharing the same, all the contact details with Pankaj sir. I think so you can take it from him. Sure, we'll definitely plan, Miriam. We can do that.
Pritesh, are you here?
Yes, sir.
Yes, sir. Hello, Pankaj sir.
Yes, sir. Please proceed for the moment facilitation, sir.
Okay, Nityanand, you may proceed further.
Thank you, sir. Thank you, Mohammed Amir, sir. It was such a nice lecture, and I think everybody enjoyed a lot. And you have a very high level of knowledge and a skill. And thank you for all this. And as a token of respect and appreciation, sir, I am just presenting e-memento and a certificate of appreciation for you, sir.
Thank you. Thank you so much, ma'am.
So nice. And again, from AKGIM, all the faculty members, Ritesh sir, on behalf of Ritesh sir and Pankaj sir, thank you so much, sir, for being with us. And for certificate, etc., Pankaj sir, I think Pankaj sir will do all these things.
Yeah. Thank you, Nita ma'am, and thank you, Ahmed sir. I know that you have another session, and I think you are late for that for 5 minutes. But thank you so much to you actually take out the time from this busy schedule.
No worries, sir. Thank you.
sir.
Thank you so much.
I request all the participants to stay here for almost 5 to 10 minutes time. We here itself will give away the e-certificates to everyone, and the copy of that in soft copy we will be mailing to you today itself. Pratik sir, are you here?
Yes, sir, I am there.
Thank you so much, and you are so kind that you accept my invitation to be here in the validity session. I'm so thankful to you that you with all possible interaction we try to build up a program which actually is a suitable program for the beginners. So thank you so much, sir.
That's our pleasure, sir. And I hope participants must have enjoyed the sessions, and they, as I can see from the chat box as well, everybody is appreciating the effort, and they say that they have definitely learned something. And yes, definitely, if given a chance in future as well, we'll keep organizing more such events.
Definitely, sir. Definitely, sir. Now, just give me 1 second. After this, is the slide visible?
Sir, it is visible.
Okay, thank you. So, Jain to dear participant and my dear faculty colleague, on the onset of this validity session, let me briefly tell you about AKGIM. AKGIM is among leading affiliated management colleges in the Uttar Pradesh. We have been actively involved in conducting FDP, MDP training program, workshop on the contemporary topics in the thrust skill domains. This year, AKGIM has set up Center of Excellence for Data Science and Business Analytics. Here we have developed modules for basic and advanced category of learners in the area of data science and business analytics, including training programs for SPSS, AMOS, R, Python, and MS Excel. As far as the learning from the session is concerned, I believe and I expect that these 5 days could have laid the basic foundation and the motivation for the further learning. In these 5 days, sessions were delivered by Mr. Pratik Vasishtha, Mr. Azib, Dr. Dushyant Tyagi, and Mr. Amir. All these sessions in totality cover the basics of machine learning, basics of Python. We got to know how to install Python. There are few who for the first time are trying this language. We have the session in the area of data visualization, descriptive exploration of the data to develop insights, and today the session was on predictive analytics. Moving forward, we thank the parent organizations of the participants who have joined us from different parts of the India. These are the institutions. Just to mention, participants have joined us from Hyderabad, Raipur, Imphal, Pune, Jalgaon, Lucknow, Aligarh, Satara, Jaipur, Ahmedabad, Aurangabad, Maharashtra, apart from Ghaziabad, Hapur, Noida, Greater Noida, and Modinagar. So we are very, very thankful to all the participants because it's really difficult to take out time in the evening once you finish your office. So thank you so much. Now, before we move on to the e-certificate, kindly allow me to propose vote of thank to all those who made this FDP possible and successful. We are thankful to AKGIM authorities who motivate us and back up by various required resources. We are thankful to our associate partner, Ghaziabad Management Association, GMA. I thank to all the participants who attended this program for 5 days in a very disciplined and mature manner. Without the participants, this FDP could not be successful. So thank you all the participants for your active participation and patientful learning, patientful devotion. We thank our faculty colleagues who were so supportive and contributing to this FDP. Last but not the least, thank to Almighty God for give us the blessings, guidance, courage, and inspiration. Now here are your e-certificates. What we have planned is that we have posted the e-certificate on the coming slides. I request all the participants to open up their cameras so that we can have memorable photographs here. And you can take the screenshot of the certificate. Else, we are also sharing the certificate today itself. So here is the certificates. Dr. A. Srinivasa Rao, Karishma Singh, Bhavna Goyal, Dr. K. Nagia, Dr. Preeti Arora, Ajay Singh, Dr. Harshvardhan Kothari, Dr. Sana Sam Somkanta Singh, Dr. Vaishali, Gajendra Babu PGK, sorry, yes, Gajendra Babu PGK, Kishore Kumar, Mariam Siddiqui, Pradeep Verma ji,
Definitely, sir. It is very wonderful and very knowledgeable sessions. And although it's mentioned for the beginners, but somehow every expert try to bring the session into the depth and try to explain each and every concept very clearly and handle all questions very calmly. So thank you, organizers, for organizing such a workshop, and we are waiting for any next workshop in the same field.
Good evening, sir. Yeah, so, myself from Hyderabad, sir. I am Gajendra Babu, PGK Assistant Professor. I'm dealing with the business analytics classes, sir, in my college. So at the outset, I thank organizers and all the resource persons who have taken classes for these 5 days. Really wonderful sessions, sir, and organizers they did nice sessions and very rich, experienced resource persons, and we are. I think this is one of the best sessions programs I attend ever in my service, sir. Thank you, sir.
Hello, sir. Yes, sir. Hello, sir. I am Dr. K. Nagaya from ICFA University, Raipur. So I am electronics and communication area. Sir, even I am very, very thankful to the organizers and the resource persons because I have attended many training programs. Even I am a soft skill trainer. I conduct training programs here and there throughout India. But these sessions are planned practically as well as theoretically hands-on. That is the main thing. And I salute and acknowledge all the trainers and the resource persons and the managements and all the participants and colleagues also. Thank you, sir. Even the handling process and questions and even the while programming also, each and everything they have given. I thank everyone my bottom of the heart. Thank you, sir.
Thank you, sir. Thank you, sir. These kind of comments actually encourage us. And so far, the program integration is concerned. Most of the credit goes to Mr. Pratik, who is also here, because he has been involved in this for last almost 1 month time. We were in discussion what to include, what not to include, because the program is for beginners. So where to start, what to not focus on much. So this all been into continuous interaction. So thank you so much, sir, for mentioning this as a feedback.
Yes, sir. Actually, right now I am traveling. I am in bus, Hyderabad, Raipur to Hyderabad. Without missing any second, I joined before 10 minutes. Even I am attending. Thank you, sir.
Thank you, sir. So kind of you. Thank you.
Thank you.
Dr. Ajay Singh, are you here, sir?
Yes, sir, I'm there.
Sir, excuse me, sir. You said that
First of
today.
all,
Excuse me, sir. Am I audible?
Yes, sir. Yes, sir.
Sir, today you said there is another session, sir, on the visualization, sir. When is it, sir? Data visualization, sir.
Data visualization is covered in the third session by Mr. Ajib, who actually explained how to plot the curves and graphs and how to edit all those stuff that was there. Okay. Although we have planned a small session on the Tableau, which I think Mr. Pratik also mentioned in the first session. But point is today the resource person has another session, so he has to go, and therefore we were not able to conduct that in that particular software.
Okay, sir.
So Ajay, sir.
Yes, sir. It was very well organized, sir, and resource persons were extremely, very knowledgeable and we have really enriched our knowledges. And I would like to congratulate AKG. They are always the leader, and they have also set up the Center of Excellence, which was, also in my thought, in my mind, and I was requesting for management also to set up the Center of Excellence for data analytics and Python. Although we have started one course of business analytics, but unfortunately, not many students we can get. So this is, this FDP was, especially I have learned a lot, and I think now I have a good knowledge of statistics. But again, these technologies have made things so easy, so we can visualize the data, and we can organize, and we can present the data much more, deeply as we normally use with other software. So very well organized, and the only request is next time do it physical mode so that we can give full time, right? Because this is not a this is not a kind of work which we required after our working hours, because it should be taken in our working hours, and we should be dedicatedly, because learning teachers should always learn out things. It's not like anything extra. It is a part of learning, and that we will be delivering to our students also. Right. So it should be full-fledged organized, in-campus organized, full-day sessions, further, definitely will, I would like to be the part of it. Thank you
Guys,
very much.
we try our level best to arrange another FDP on the similar
Right,
track.
sir. Thank you so much.
Do we have Dr. Shashank here? Shashank, sir. Sir, since you are from the technical background, so your comment would be a value addition for us. So please unmute yourself.
Sir, your FDP is very nice, very good. It is a balance between theory and a practical aspect. And I also learn a lot from the practical on the Python. The trainer is very expert and knowledgeable. The main point is how to present the practical knowledge to the audience. That is a very important thing, because at the starting, if you putting everything and then it is difficult to understand. But he has taken a step by step to explain the practical knowledge and how to go about the linear regression. And it's a very nice, good trainer and nice FDP. Thank you very much. Thanks for me to give the opportunity, sir. Thank you.
Thank you, sir. Thank you so much, sir. Do we have Dr. Vaishali? Dr. Vaishali? Okay. Miss Mariam Siddiqui would like to add something. Miss Mariam Siddiqui? Okay.
Thank you so much, sir. Dr. Shakuntala Mishra, I am from, and Dr. Dushyantagi, sir, to me, blessed honor to be participate on this platform Python network. That is, I'm beginner to join this session, but as I'm just more encouraged that to do, and in this field, this future is bright, but depends on the courage and more classes are attend
Practice.
to in this section. Yes, practice all. So that thank you so much, Dr. Shakuntala Mishra, and
Thank you.
so
Thank
thank you,
you.
sir, and you too, sir. That's it's honor to I have this session. It's more courage to me to. I just want to show that in future I will definitely join this session if you
Thank you. Thank
conducted
you, Mariam.
and
Thank you so
let me
much.
join this. Thank you so much,
Thank
sir.
you. Thank you. Dr. Tejshri, are you here? Dr. Surbhi? Mr. Sanasam? Okay, I think, sir, now we are here to end this session. Pratik, sir, any last comment from your side?
I really appreciate the efforts all the participants have put in this workshop, and this was just a beginning. It was a foundations workshop, and but I guess this is good enough for everybody to start learning, start their journey towards the machine learning. And in future as well, I promise, as and when we are available, we are always ready to conduct more sessions. And as Ajay sir also said, next session we'll try to do it in person mode.
Physical form, right, sir? You were also with the same view, but I insist you to
Yes.
just have it on online. But yes, sir. We next time will try to have it on physical mode. Dr. Ritesh, are you here? Sir, unmute yourself, please.
Yes, sir.
Sir, your use.
So most of the participants are in favor of offline mode, but I think in that case we'll miss this mixture of the audience. People are from joining from northeast, people are joining from south, northeast, northwest, and south. But in case of offline mode, only uh, only the participants in a circle of 100 kilometer, maybe more than not more than that, will join us in that case. So online we have a leverage of this kind of thing. In all, this program is very well organized. क्योंकि मैं अपनी तारीफ ही कर रहा हूँ. So this program is very well organized by Pankaj sir, and all the experts are lined up in a you can say like a data storytelling. First of all, we'll discuss what is machine learning, and then step by step we move ahead to the predictive learning. So thank you, Pankaj sir, and thank you all the participants to be with us. And we are going to conduct next two program in this in next 1 or 2 months. This program is you can see on the screen. This is the 5-day FDP again from 26th to 30th September in the same month only, and especially in the area of HR. You can join this FDP. And another program is the international conference that is being conducted in the month of November itself. So you may join all these programs. Thank you, Pankaj sir. Over to you.
Sir, thank you. Thank you.